Hi students, this is Mr. Yao. Today we are going to start a new unit, and this unit is actually quite related to what we have learned 2 units ago, which is circles. First lesson is called ellipse, which in plain English word is just an oval shape, but it is quite related to circle. So let's review something we have learned before. For A, that is the equation for circles. From that equation, we can identify the center and the radius. To remind you, the equation for circle was x minus h squared plus y minus k squared equals r squared. So the h and the k would represent the center, and in this case, it's going to be 6 and negative 7. Remember, it's always going to be the number that's opposite to what's given, because we want that part to kind of equal to 0 and then solve that part. The radius, well, it's on the right side. 36 is r squared, so that means my r is going to be a 6. For B, you are given the center and the diameter and is asking to write the equation. The diameter is not an equation, but we need the radius from the diameter, so half of it, a 3. That's why the equation is going to be x plus 2 squared plus y minus 4 squared equals to 3 squared, which is 9. That's B. C, finding the midpoint of these 2 points basically means we're averaging the x coordinates and the y coordinates. So for the x, negative 3 plus a negative 2 divided by 2. For the y, 4 plus a negative 3 divided by 2. That would simplify to be a negative 5 over 2 and a 1 over 2. That's question C. Now we're moving on. Question A, if we divide both sides by 36, what would it be? So have a look at it again. Everything on the left side is not divided. So I'm basically dividing that fraction, that first part by 36, that second part by 36, the 36 by 36. That would give us something like this. X minus 6 squared over 36 plus y plus 7 squared over 36. These two denominators are the same, and they both represent the radius squared. And then the right side is a 1. So that's an equation for a circle. Now, what if the denominator is actually not the same? What would it change? So just a rough thought, if they're not the same, that means we're not having r squared down there, then we can actually have a radius, but that means we're still going to need some kind of points to represent the distance, because again, the definition for r is the distance from the center to any point on the circle. That's the radius. So if we don't have that, that means the distance would change. So that gives us the shape that's called ellipse. An ellipse is the set of points on a plane whose distance to 2 fixed points add up to the same value. I gave you a link that's like a program that you can check that actually give you a rough look of how it changes from a circle to an ellipse, how they're related. So again, the definition is the distance to 2 fixed points add up to the same value. So if you recall the definition for a circle, that would be to 1 fixed point is always the same. And that distance would be the radius. Here, 2 fixed points. The 2 fixed points are actually called the foci, and which is the plural form of focus. So circle, in a way, is actually it's a very special ellipse. For ellipse, instead of the same denominator being r squared on both parts, they're actually different. So now, let's get more into the ellipse. The equation for the ellipse at the origin, center at the origin, x squared over a squared plus y squared over b squared equals 1, and x squared over b squared plus y squared over a squared equals 1. If you didn't notice, the only difference between these two equations is the a and the b, their positions. So typically, we say a is the bigger number. That's kind of how it is. It's not like there is something that's specific a, that's specific b. It's just the bigger number. So in that case, depending on where a is, for example, the first equation, a squared is under x squared, that tells me something. For the second equation, the a squared is under y squared. So it's just if the bigger number is under x or under y, because that is going to decide the major axis. The major axis is determined by whichever is bigger out of the a and the b. The major axis length would be 2a. The minor axis, the length would be 2b. So let's have a look. These are 2 different possibilities. The first one, as you can see, this x horizontal part is actually longer. that corresponds to x squared over a squared plus y squared over b squared equals 1. As for the other one, you can see the y part is bigger, so of course the a would be under the y. So the second shape corresponds with x squared over b squared plus y squared over a squared, which equals to 1. So for this one, that will be the major axis right here, which means my length for the major axis is actually 2a. So this part will be an a, and that part will be an a. That means we can also write down the points. That point would be a0, and that point would be negative a0. Then, of course, we also have the other axis, which is called the minor axis. So let me write down the word. This, well, not this. This is in that kind of setup, the major axis. The shorter one would be our minor axis right here. So that means this length is b, that length is b. The whole thing is our minor axis, which means you can also write down the coordinates. That would be a 0b. This would be a 0, negative b. For the other one, of course, everything is kind of flipped. Because our longer part is on the y, so this would be our major axis in this case. That part is a, that part is a, so we have 0a and 0, negative a. And that, again, is our major axis. Then, of course, the shorter one would be our minor axis. So from here, left to the right. And that will be length of b and a b, so that gives us the points. b0 and negative b0. So this axis would be the minor axis. That's why the length, total length, is adding up to 2, the b and the b, so 2b. Moving on. The foci are always located on the major axis. We don't exactly know where the foci is when we just draw some random things because we don't have numbers that we can use. But the relationship between A, B, and C is right here. C is found, now the Pythagorean Theorem is not a squared plus b squared, it's actually a squared minus b squared, which should make sense because A is the major axis and is longer than B, so we're going to do a squared minus b squared. So roughly our C could be C here and another C here. They got to be symmetric. That is negative C0, and that would be C0. And same thing here is on the major axis, so our C might be here. That is 0, negative C, and this will be up top, so 0, C. These are just two different setups. Moving on, vertex. The vertices are the endpoints of the major axis. So very specifically, these, the negative a0 and the a0 in this format, and the 0a and 0 negative a, these are our vertices because they are on the major axis and they are the endpoints of these major axes. Last little bit, the distance from any point on the ellipse to the two foci add up to 2a. So that is basically saying from any point on the graph, let's connect with the two foci, these two portions will actually add up to be 2a. Same thing, let's say you have a point here, that portion and the other portion, they will add up to the full major axis. So these are some definitions. Now let's move on. Time to identify some parts. Identify the center, vertices, and foci of the ellipse. For example, what? It's just x squared and the y squared on the top. So of course the center would just be 0, 0. Let's put a point at 0, 0. Next, we are going to work with the the major axis. So the major axis, 16 is bigger numbers, and that's under x. So that means in that case, my a would actually be 16 square root of that, which is 4. So that gives us our vertices. The bigger number is on x, so that means the vertices are going to be the x values. So negative 4, 0, and 4, 0. So we can go from the origin, negative 4, left 4, 0, and then right 4, 0. And if you still haven't noticed, we basically could have counted 4 from the center. because that's what the little a represents. It's basically from the center to one vertex. Next, I'm going to find my foci. But in order to find my foci, of course, I'm going to need to find my b first. My b is from the other number under y, which is square root of 7. So to find the foci, the relationship is c squared equals a squared minus b squared. So in that case, we are going to do c squared equals 4 squared is 16 minus 7 is a 9. So my c would actually be a 3. So b is square root of 7. Of course, we're going to need to put these 2 points down for the b, which again are called co-vertices. So I'm going to change into a different color. That is what we need, square root of 7, which is close to like 2 point something. So we are just going to go from the center, go a bit. Let's just say that is square root of 7, and that is also negative square root of 7. So we can actually connect them to draw the shape. Roughly. It's roughly the shape. So that is this example 1. Kind of just getting used to a lot of definition. Now, moving on, example 2. For this one, it's actually not even in that format that we want. And the format is x squared over a squared plus y squared over b squared equals 1. So we want the right side to be a 1. That is why we are going to divide everything by a 49. So we have x squared plus y over 7 squared equals to 49 over 49 is a 1. Oh, why did I write it that way? Should have been y squared over 49. There we go. Now you can see, basically that is x squared over 1. So first I know my center. It's going to be 0, 0. And in that case, we can also look at the equation and start thinking about what is our a. A's got to be the bigger number under x squared or y squared. So the 49 is a squared. That means my a is actually going to be a 7. So let's put the center 0, 0, and let's deal with the a equals 7. So we're going to put it left 7 positions and then right 7 positions. And of course, we want, oh, that's not 7. That is actually 9 right here. Okay, next we are going to identify our b. It's got to be the smaller number. So my b in this case would be a 1. So I'm just going to go 1 up, 1 down. In case you still haven't noticed, the a, b, and c, whenever I'm using them, I'm starting from the center. Just because the center is origin, that makes these things easier. Next, I'm going to solve for my c. C squared is a squared minus b squared, which is basically 48. So c would be square root of 48, which is 4 square root of 3. And of course, you can choose to put in some rough points. That's going to be super close to the side. So I'm just going to put a point there, put a point there. So now we can actually connect this very flat matrix. That is example 2. Moving on, example 3. This time you are given the vertices and the foci. Look at the vertices, you see the numbers are 10 and negative 10. It is asking you to write the standard form of the equation. So with 2 given vertices, we can easily identify the center. The center is going to be the midpoint of the vertices, so 0, 0. Next, from the vertices, we would know our a is going to be a 10 because both points are 10 away from the center, so that's why our a is going to be 10. And however, we don't know our b. But we do know our c, which is 5 square root of 3. And something you may have not noticed, for foci and vectors, the numbers that we just used, they are both on the major axis, which means my major axis are going to be x, since these two are our x coordinates. Now we can find our b, so 5 square root of 3 squared equals to 10 squared minus b squared. And in that case, we can figure out our b is actually a 5. So I can start writing my equation, x squared over, my a is 10, so it's got to be 100 under the x squared, then y squared over 5 squared is 25, equals to 1. Now we can repeat the same process for example 4. First, the center. It's got to be the average of these 2 points. That's going to be 0, 0 again. And this time you may notice our big numbers are actually on the y-axis. That means it's going to be vertical as the major axis. So my A is 12. As for my B, we are going to calculate it out. That's a C, so we know C squared is 119 equals to x squared, which is 144, minus a B squared. You may figure out our B squared is actually 25, so B is yet 5 again. Now we can write our equation x squared over, this time the A is on the vertical one, so of course it's not under A squared. It's got to be the other number, the B squared, so 25. Then plus y squared over 144. And that is equal to 1. That is example 4. Moving up. Example 5. Now we just need to use the graph to identify. That's actually super easy because we can easily identify our A centered at the 0, 0. So our A would be a 5. In that case, our B would be a 4. And clearly, that's the major axis because that's longer. So A is under the x. So x squared over 25 plus y squared over 16 equals 1. Moving on, same idea, but this time the major axis is actually vertical. So that means my A is actually going to be a 3, and my B is actually going to be a 2. So x squared over 9 plus y squared over 4 equals 1. That is example 6. Oh, I actually had it backwards. My y should actually have the 9, and x squared should be the 4. Because the A is vertical, so y squared has the bigger number below it. Last 2 questions, example 7 and example 8. Center at the origin, major axis is horizontal. Great. That tells us that A squared is going to be under the x squared. Major axis is 20 units long. If you remember, major axis is 2a, and minor axis is 2b long. So I would know my A is 10, and my B is square root of 70. Since it's horizontal, my A would be under the x squared. So x squared over 100 plus y squared over, well, it's a square root of 70. So it's got to be 70 because when we square that number, it's got to be a positive 70. That equals to 1. Example 8. This time major axis is vertical and major axis is 2a again, so A is 6. Minor axis is 2b, so B is going to be a 4. Is that the origin? All we need to do is put the numbers in the right place. So x squared over something plus y squared over something equals to 1. And in this case, our major axis is vertical, so the bigger number goes under the y squared. So A squared is under y squared, which is 36. And the other one is going to be the b squared, so 4 squared, that is 16. And that is the first lesson, 8.1a, number 1, ellipse. Thank you.